Hi guys. So today we will solve one of the Geek for Geeks question. Okay, so this question you will find anywhere, whether it is lead code or Geek for Geeks. So let's take it from here. So the question says a sub array with a given sum. So we need to find out a sub array which will have the given sum. So let's understand this question. Given an unsorted array of A of size n that contains only positive integers, find the continuous subarray that adds to the given sum S and return the left and the right index, one based indexing of that subarray. So what it is saying that our array will be unsorted, it will be of size n, it will have only positive integers, and we need to give a continuous subarray. We cannot give a sum which is like 1 plus 3 plus 5. We cannot give like that, so it should be continuous. Okay, and we need to return the start and the end index, it is left and the right index, and it is saying that it is one based indexing. What it means, like our index doesn't start, we need to make an assumption that our indexes doesn't start from 0, it starts from 1. So this we will handle as part of our result. In case of multiple subarrays, return the subarray indexes which comes first on moving from left to right. So if you have multiple subarrays which is producing the same results or which is producing this given sum, even though in that case we will send the first subarray, right? Now there is a note, you have to return an array list consisting of two elements left and right. In case no such subarray exists, return an array consisting of element minus 1. Other than the subarray in which the sum is not found, we need to return an array list which will have two elements, that is left and right, or you can say start and the end indexes. But in case where the sum is not found, we need to just add only one element, which is minus 1, and return it. Let's understand this example. So it is saying from index 2 to 4, you need to understand that this is one based indexing. So here 1 means 2 means 1, so this is starts from here, and it says 4, so which means it will be 1 2 3 4, so it will come here. Okay, so 2 plus 3 plus 7, so it will become 12. So this is the output. Okay, let's understand this example in algorithm and then we'll start the coding.
Let's take the example of the array, okay, the given array, which is 1, 2, 3, 7, and 5. So this is the given array, and the sum given is 12. So now we need to find out the sub array with the given sum, okay. So when we say here like a sub array means the contiguous array, right? Let's start from here, from the start. So if we have a variable called sum, which is initialized to 0, now we came over here. Suppose my I is here, so I came here. So I will check whether if I'll add my this variable to my this sum, will this become equal to 12 or less than or greater than 12? Okay. So now if you will add 1 to that, it will be less than 12. So I think it is safe to add it, right? So we'll just add 1 to it. Okay, now my sum became 1. Okay, now we come over here. Now what will happen if we add to my present sum? So it will be still less than 12 because 1 plus 2 will become 3, right? It is still less than my given sum. Now we'll come over here, right? Now 3. What will happen if I'll add my 3 to my given sum? 3 plus 3 becomes 6. So it is safe to add 3 as well, right? So we have traversed till here. Now we'll come over here. Now what will happen if I add 7? So 6 plus 7 equal to 13, which is greater than the given sum. Here, what we will do, so we will try to include this because still now we did not get the sum 12, right? So what if we want to include the 7? So once we include the 7, then it's better to reduce it from this side. This is what is called sliding window. You have a window. Suppose this is the window and you have numeric values over here. Okay. So you're traversing, your window is over here. Currently, your window is over here. Now you extended the window since it was safe till this point of time. Now you've increased the window till this as well because it was safe. Now, once you included this in your window, your window is not safe, right? It has become greater than 13, which is not our intent. So what we will do, since it is sliding, so we will increase it from there. Okay, so now our window will become from here to here. Okay, so what will happen, so we have added 7, so it became 13. Now we have reduced 1, so we'll subtract 1, so it will become 12, right? So with this window as a subarray, since it's contiguous, right? So it's a contiguous and the sum is 12. And once we get the sum, we'll just return it. So if we'll use 1, 2, 3, this, it was 1, 2, 3, 7, 5. Okay, this was my array, and this is my index 0, 1, 2, 3, 4. So this was my starting index. So this was my starting index, and this is my ending index. Okay, so it will become 1 and it will become 3. Okay, since it is a 1 based index, so you will return 2 and 4. Okay, that will be our output. Okay, so let's start coding for that.
So now we have understood this, let's start coding for this. So let's handle some basic cases first. So we'll create an array list for our response. Okay, now we need to handle one corner case. Like if our given sum is 0, then what we can do, we no need to do anything, we'll just add -1 and return the response. Okay, in other cases what we will do, we'll take a start index which is 0, we'll take a end index which is 0, and we'll take a sum variable which will hold up a sum while traversing through the array. Okay, now we'll have a while loop. Okay, so for this while loop, end is less than our n. Okay, now what we have understood, if our sum, my present sum plus my present element data, if I'll add it, if it is lesser than or equal to what sum I'm going to produce, so I'm safe to add this sum to my variable, right? Else, suppose it has become greater than 12. Now in this case, I'm sorry, it's not I, it is end. So in else case, we will just subtract the data from the sum, right? Start plus plus, and we'll start reducing from the start. Okay, so we will just start reducing the window. Now we'll check if our sum is equal to our given sum or not. In this case, now we will add to our response start end, and we'll return the response. Now since we are handling the end properly, right, we are always at the end and we are doing the plus plus. Okay, so end, so once you will come over here, suppose you are here, right? Now you come over here from 3 to 7. Now our end is over here. Okay, now if we are here and we have included the sum 7, even though after that we are not doing anything, our end is automatically getting plus plus. Okay, so instead of 0, 1, 2, 3, it will be 4 automatically. So our end is fine. Okay, but in case of start, so initially our start was 0, and when we reach the 7, we need to start reducing it, right? So once we reduce this, we came over here, it is at 1. Okay, so we did the minus and we came over here 1. Okay, so it will be from 1 to 3. okay, but it should be 2, right, since it's an index based. So we need to manually do +1 for the start and not for the end. Okay, now so we are returning once we get the result. If our code is not returning from here, if our code is not returning from here, this means that sum doesn't exist, right? So once the loop is completed, I think we need to add one more. So once our loop is completed, then we'll just add the response -1 and we'll return the result. Okay, so it's fine. Let's submit it. That's it for this video. See you in the next. Thank you.